Welcome to the deep dive. Today, we're tackling something I think a lot of us in the software world have felt.
Oh, yeah. What's that?
That feeling that testing always seems to happen, right at the last minute. Or it misses those weird bugs that only pop up once the thing is actually live.
Ah, yes. The classic works on my machine, but breaks in production scenario. Definitely familiar.
Exactly. So we're going to dive into shift left and shift right testing in DevOps today.
Good topic. It's really about how the whole approach to quality has, matured.
Our mission really is just to cut through some of the jargon, give you some clear, relatable insights. We looked at some really good material that breaks this down quite well.
Yeah, it's key to understand we've moved past testing being just a gate at the very end. It's more woven into everything now.
Okay, so let's start with shift left. When we talk about shift left testing, what are we actually saying? What's the core idea?
Basically, it's pretty simple. You move testing activities earlier, much earlier in the software development lifecycle.
Instead of waiting right until the end.
Exactly. The old way, development finishes, then testing starts. It's like building a whole house and only checking the foundation right at the very end.
Right, and if you find a problem then, oh boy.
It's a nightmare. Hugely disruptive, expensive to fix. You might have to tear things down and rebuild.
So shifting left avoids that kind of pain. What's the main benefit?
The big win is catching problems when they're simpler and, frankly, cheaper to fix. Think about baking a cake.
Okay.
If you realize you use salt instead of sugar right at the start, easy fix, right? But if you only taste it after it's baked and decorated, well, you're starting over.
Ah, okay, good analogy.
Yeah.
So find the salt early. It saves time, saves money, speeds things up overall maybe.
Definitely. Less rework means faster cycles. And you build up less technical debt, too. It's a win-win.
Makes sense.
Mm-hmm.
So what does this look like in practice, like day-to-day for a team doing shift left?
Well, one key thing is starting to think about tests, even writing test cases, right when you're figuring out the requirements.
So even before coding starts?
Yeah, absolutely. It helps clarify those requirements for everyone, make sure everyone's on the same page about what done actually looks like.
Okay, what else?
Then there's the developer side, running unit tests frequently, ideally, like every single time they commit or push code.
So those really quick checks that catch bugs almost as they happen.
Precisely, at the most granular level. Another thing is automated static code analysis.
Ah, the linters and scanners.
Right. Tools that scan the code before it even runs. They look for potential bugs, security flaws, style issues, that kind of thing.
Okay. And what about the testers themselves? Where do they fit in early on?
Big one. Involve them in sprint planning. Seriously. Their perspective on, potential risks or how something could be tested can shape how it's built right from the get-go.
So they're not just waiting at the end, they're part of the conversation from the start.
Exactly. It helps prevent issues before they even become code sometimes.
All right, so that's shift left, moving things earlier, catching issues sooner. Now let's flip to the other side. Shift right. What's that all about?
Shift right is focused on testing and learning after the software is deployed. When it's live, in production, being used by real users.
Okay, so testing in the wild, basically.
You could say that. The goal is to see how it really behaves under real-world conditions and how users actually interact with it. Things you just can't perfectly simulate in a test lab.
So what kind of activities fall under shift right?
Several important ones. Monitoring is huge, real-time monitoring specifically.
Using tools like, what were the examples? New Relic, Sentry?
Yeah, tools like those. They watch performance, track errors, see what users are doing. Then there's observability.
Which is different from monitoring.
Kind of the next level. Monitoring tells you if something's wrong. Observability helps you understand why it's wrong, even for problems you didn't expect or plan for. It gives you deeper insights.
Okay. And you mentioned chaos testing. That sounds a bit intense.
It does, doesn't it? But it's super valuable. You intentionally introduce failures, like shutting down a service or adding network latency in your production environment.
On purpose. In production.
Yeah, but in a controlled way. The idea is to test how resilient your system is. Does it handle the failure gracefully? Does it recover? Better to find out during a controlled experiment than during a real crisis.
Okay, I guess that makes sense. Stress testing it for real. What else?
A/B experiments are another form. You release slightly different versions of a feature to different user groups and see which performs better. That's testing in production too.
And just listening to users.
Absolutely. Gathering user feedback, bug reports, surveys, reviews, support tickets. All incredibly valuable data from the real world.
Okay, can you give an example where shift right really shines, where it catches something shift left might have missed?
Sure. Imagine a mobile banking app, tested extensively, works perfectly on all the simulators and test devices, but after launch, crash reports start coming in.
Oh, no.
But only from users with, say, a specific older phone model running a slightly outdated OS version doing one particular type of transaction.
Something you just didn't have in your test lab.
Exactly. Real-time error monitoring, a shift-right practice, would likely flag this spike immediately. It points you right to the specific conditions causing the crash, so you can fix it quickly. You probably wouldn't have caught that pre-launch.
Right, too many variables in the real world. Now, you also mentioned deployment strategies playing a role here, like canary releases.
Yes, definitely. Things like canary deployments or blue-green releases are key to doing shift-right safely.
How does a canary release work again?
With a canary, you roll out the new version to just a tiny fraction of your users first, maybe 5%. Then you watch it like a hawk using your monitoring tools.
See if the canary survives.
Kind of. If performance is good, no new errors, then you gradually increase the percentage until everyone has the new version. If things go bad, you roll it back, and only a small group was affected.
In blue-green.
Blue-green is having two identical production environments. Let's call them blue, current live, and green, idle. You deploy the new version to green, run final checks, maybe route a little internal traffic there. Once you're happy, you flip the switch, and all traffic goes to green. Blue becomes the idle backup, ready for the next release or a quick rollback if needed.
Smart. It's like having a safety net for your deployments. Feels a bit like launching a new snack food. You give out free samples first, see the reaction.
Yeah, exactly. Test the waters before going all in. So shift left prevents issues. Shift right helps you learn and adapt from reality.
And the key point is, they're not enemies, right? They work together.
Absolutely not enemies. They're complementary. You really need both for a robust quality.
How does that synergy actually play out? How do they make each other better?
Well, shift left is your prevention. It stops a lot of bugs ever reaching users. But shift right provides that crucial feedback loop from the real world. It tells you what you missed, how users really use the software, and where the unexpected problems are.
So shift left reduces the noise, and shift right helps you find the signals you might have missed.
That's a good way to put it. And the insights from shift right directly feed back into shift left. If you find a certain type of bug in production, you add tests earlier in the cycle to catch that specific pattern next time. It's continuous improvement.
It's like fire safety. Shift left is like using fire-resistant building materials, and shift right is like having smoke detectors and sprinklers.
Perfect analogy. You need both prevention and detection response.
Are there specific tools that help bridge these two worlds?
Yeah, definitely. CI/CD pipelines are fundamental. Tools like, Jenkins, GitHub Actions, GitLab CI, they automate the build, test, deploy process, enabling both early tests and controlled releases.
And the testing tools themselves.
Automated test suites are critical for shift-left things like Selenium or Cypress for UI tests, maybe JUnit or PyTest for unit tests. And then for shift-right, you absolutely need good monitoring and observability tools.
Yeah.
Datadog, Grafana, Splunk, Elastic Stack. Lots of options there.
So the tooling is pretty important to make this all work smoothly.
It enables it, for sure. Automation is key.
Now, with testing happening early and late, and being so integrated, what does that mean for people's roles? Is it still just the QA team's job?
No, not at all. That's one of the biggest shifts in DevOps culture. Quality becomes everyone's responsibility. It's baked into the whole process.
So how do different roles contribute? What are developers doing, for example?
Developers are absolutely critical. They're writing the unit tests, the integration tests. They're thinking about testability as they code. They own the quality of their code at that fundamental level.
And QA, what's their focus?
QA often evolves. They might lead the charge on building more complex automated tests, end-to-end API tests. They bring deep testing expertise, championing quality practices, maybe doing more exploratory testing to find those edge cases automation might miss. They become quality coaches, almost.
Okay. And ops?
Yeah.
Operations teams.
Ops teams are crucial for the shift right side, naturally. They set up and manage the monitoring, the alerting, the observability. They ensure the production environment is stable, and they're often involved in those controlled rollouts, like canary releases. They own the reliability in production.
So really is a team sport. Everyone owns quality.
That's the mantra. Breaking down those old silos, dev, QA, ops is essential. Everyone works together towards that shared goal.
Does this tie into things like agile practices?
Absolutely. Things like pair programming, where maybe a dev and a tester work together on a feature in its tests. Or the idea of T-shaped skills, having your specialty, but also understanding other areas. It encourages developers to think about testing, testers to understand deployment.
And planning together.
Yeah, collaborative test planning involving everyone early on ensures the testing strategy aligns with the development goals and covers the real risks.
Okay, let's try and make this super concrete. You mentioned an e-commerce platform example earlier. How would shift left and shift right look there?
Right. So imagine they're adding a new feature, like a personalized product recommendation engine.
Okay.
In shift left, developers writing unit tests for the recommendation algorithm itself. Does it pick relevant products? They'd also test the APIs that deliver those recommendations, maybe using something like Postman.
And QA?
QA engineers might build automated UI tests with, say, Selenium, checking if the recommendations actually show up correctly on the web page, if clicking them works, if it doesn't break the layout on different browsers.
And these tests run automatically?
Yeah, they'd integrate all these tests into their CI/CD pipeline, maybe using GitHub Actions. So every time code changes, these checks run, catching issues early. That's the shift left part.
Got it. Proactive checks. Now, the recommendation engine goes live. What happens on the shift right side?
Okay, now it's in production. The ops team, or maybe a dedicated SRE team, is watching it closely using monitoring tools, let's say a Datadog.
What are they looking for?
Things like, how fast are recommendations loading? Are there errors? And importantly, is the feature actually working? Are people clicking the recommendations? Is it increasing sales or maybe even decreasing them?
Ah, so business metrics too.
Yes. And let's say they notice something odd. Maybe a spike in errors on product pages, but only when recommendations are shown. Or maybe conversion rates dip slightly after the rollout.
Okay, the monitoring flag's a problem.
Right. That's the shift right detection. This triggers an investigation. The team dives in, figures out the root cause. Maybe the algorithm performs poorly for users with no purchase history, causing errors or irrelevant suggestions.
And then the crucial part, the feedback loop.
Exactly. They fix the bug, but they also go back and add new tests, unit tests, integration tests, maybe even specific monitoring checks to cover that exact scenario they just found in production.
So it won't happen again.
Precisely. They feed the learning from production back into the earlier shift left stages. That closes the loop.
So that e-commerce example shows the whole cycle. Proactive prevention, reactive detection in production, and then adapting the earlier tests based on what you learned.
Exactly. It's proactive, reactive, and adaptive. That's mature DevOps testing in action.
That really clarifies it. Okay, for listeners wanting to maybe implement some of this, you mentioned some checklist items. Let's recap those quickly. For shift left.
Sure. Key things for shift left. Get unit and integration tests running automatically in your CI pipeline. Use code linting and do solid code reviews. And definitely automate API tests before merging code. Basic hygiene, really.
Good practical steps. And for shift right.
On the shift right side, think about using feature flags or canary releases for safer rollouts. You absolutely need real-time monitoring of production and invest in good logging, alerting, and observability so you can understand what's actually happening out there.
Excellent. Really actionable points there. So as we wrap this up, what's the big takeaway, the core message about shift left and shift right?
I think the main thing is that testing in DevOps isn't just a phase you pass through. It's really a mindset. It's about building quality in everywhere, all the time.
From the very first idea all the way to running in production and learning from it.
Exactly. And it's not one person's job anymore. Quality is that shared goal developers, testers, ops, everyone.
We need shift left to catch things early and prevent problems.
And we need shift right to learn from reality, adapt quickly, and handle the unexpected things that inevitably happen in complex systems. They really do work hand in hand.
So maybe the final thought for you, the listener, is where in your own workflow can you start thinking with these shifting perspectives?
Yeah, how can you bring testing just a bit earlier? Or how can you get better visibility into what happens after you ship?
Even small steps towards that shared culture of quality can make a big difference. Something to think about. Well, this has been a great deep dive. Thanks for sharing your insights.
My pleasure. It's a fascinating evolution in how we build software.